Good afternoon. Let me quickly introduce myself. My name is Vorlicek. I've been on or I should say I've been at Microsoft since 2007, first working on the advertising server stuff, then moving to Midori, as Tomas has already mentioned in his presentation. And then we've moved together to the CLR team, where just in time for porting core CLR to basically making open source and porting it to Unix. My initial work in the core CLR team was basically making all the port together with two other people, and especially doing the exception handling stuff, which was very different on Linux or Unix in general, that doesn't have the centralized exception handling mechanism like Windows does. So after some years working on various low stuff, I've also had a chance to work on the unloadability. This was a feature that was requested for a long time by people because we've basically removed support for app domains in .NET Core, and so there was no way at that point to allow unloading assemblies, because that was one of the main usages of app domains. And so let me first describe what are the goals of unloadability. What is it good for? You basically want to be able to, or users want to be able to load assembly and its dependencies into the unloadable assembly load context in the new world. You can have multiple of those contexts at the same time, and then later on you can unload the assemblies when you don't need them anymore, either by explicitly calling the unload method on the assembly load context. That, by the way, has to be created with some special flag to be considered unloadable. And it can also happen automatically when all references to the assembly load context and the assemblies loaded into that context are gone, and GC can collect everything. One of the non-goals is forceful unload. So when, for example, you have something like thread abort that was used in the domains area, where you have, say, tight loop running in your assembly loaded in the context, and you would like to unload, you cannot force it until until the GC can collect all the stuff, and I'll describe a little bit later what exactly happens and how it works. The usage scenarios, probably the most important, are plugins, where you want to dynamically load a plugin into your application and then unload it when it's not needed anymore, and you don't want any memory allocated by the plugin to stay there, so that it doesn't keep eating memory if you load other plugins and so on. So that was the most requested thing. And also it's useful when you want to dynamically compile some code, run it, and then flush it, which could be used, for example, for website or some scripting engines. Again, you don't want to pile the compiled and jitted code forever, and so the unloadability is something that you would want in that case. How to use that? Basically, it's kind of simple to use that, but as I'll show you later, there are various complexities that makes it difficult to make it right sometimes, and you need to debug problems. But first, how to use it? You basically have you have a class that you derive from assembly load context, and call the base constructor with is collectible parameter set to true. That means that the assembly load context should be collectible or unloadable. It's basically the same term that we use for the same thing. Then it has a method called load that is called for every assembly that gets loaded by something that you load into that context. So basically the context is a method to load an assembly, and that and then all the references that assembly has are resolved through that load method. You can do two things in that method. You can return null, which means load the assembly into the default context, or use the assembly if it's already loaded there. And so basically only your own assembly will be unloadable, but all the rest will be in the main context. That can be used for things that you don't want to unload for some reason, for some shared code between contexts and stuff like that. But probably the easiest way, instead of implementing your own load method, I should also say that you can either return null, or you can load the assembly or get it from somewhere yourself by loading it from file, or just like you can have assembly object somewhere and use that. But the easiest way and the way that works best with like the configuration of the application itself is to use the assembly dependency resolver for that, where it basically automatically finds the assembly that should be loaded by versions and stuff like that based on the configuration from the correct location for you, so you don't have to care about where to look for the assemblies, where they are, because it works the same way as if that assembly was loaded by default into the default context when you, for example, started an application or something like that. You can also optionally register an unload event handler for the context, which is useful in cases where you want to be able to basically make some changes before the unload can start. For example, you may need to stop threads so that they don't execute code in the assembly that you want to unload. You want to clean up some strong GC handles that could hold stuff that's inside of the assemblies and would prevent unloading, or unregister some event handlers that are pointing to the code inside of the unloadable context. Then you load your assembly into the assembly load context, and you execute the code in it, and basically stuff is running. And then when you want to unload things, then you call the unload method. And it doesn't mean that when the unload method completes, it's unloaded. It's not that way. It basically just like initializes the unload process. So it cuts some internal links so that things can get unloaded. And now it also calls the unload event. So that means that the stuff loaded into the context itself can clean up things and prepare for unloading. And then basically it's up to GC to collect all the stuff. And once GC collects everything, that all the assemblies that were loaded into that, types created from that, and so on, then the actual context can be finally destroyed and removed. If you want to know for sure that at some point the context was unloaded, or figure out the problem with unloading, you can basically, after initializing the unload, you can run a loop where you call gc collect and gc wait for pending finalizers until and check a weak reference to an assembly load context and see when it becomes that. You would probably want to loop for some number of times, and if you don't, if it didn't work for like, I don't know, 10 or 100 iterations, then you can be sure that something is wrong and the unload failed, and then you have to debug why it happened. Here is a diagram that shows basically the object relations that are a little important for understanding the unloadability. So you can see objects on top of the diagram. Each object is pointing through its method table, which is basically the identifier of the type of the object, and is the first 8 bytes in each object on the heap. Or 4 bytes in the x86 case. It points to the loader allocator managed class, and that's basically the loader allocator itself is a counterpart of a native assembly loader allocator, and this is the thing that manages everything around the unloadability. The native part holds all the native memory allocated for stuff in the context, so that when we destroy it, we can just remove it entirely instead of going one by one and just all the memory gets deallocated that way. So the object is pointing to that, basically holding it alive for the lifetime of the object. Then you have the runtime assemblies, which are basically represent your managed assemblies, and they also point to the loader allocator. So even if there are no objects from the assemblies still hold the loader allocator alive. And then there is this assembly load context that we've talked about, and the loader allocator scout that you can see there. It's basically just a helper class that allows do some proper timing around the final release of things. And as you can see that on the native side, you also have some other things that are not important for explaining the things. The main thing is that you can see that the loader allocator, everything that holds the loader allocator alive by reference is holding basically the stuff that you've loaded into the assembly load context alive. So now, what can be preventing unloading? That's what you will have to debug if you have problems. So it can be regular references that are held from outside of the assembly of the unloadable or collectible assembly load context. They can be stored in stack slots, which means local variables, or processor registers, also local variables. That can be not only the local variables that you have created, but sometimes even the JIT creates its own locals for its own purposes. So you may think that there is no local that would hold that, but JIT could have created one, and it would prevent unloading. So there could be a static variable or a strong pinning handle that transitively points to either, and all of these can transitively point to assembly loaded into the assembly collectible context, or a type from such an assembly, or an instance of a type from such an assembly. All of these things can hold it alive. So this is the first category. The second category is when threads are running code in your assembly, you obviously cannot unload it because you would basically tear it underneath. So if you have frames or functions on stack that execute that are from the unloadable assemblies in the unloadable context, you cannot unload that until they exit. Then another thing that prevents unloading, if you create instance of a non-collectible assembly load context inside of the collectible assembly load context code, I mean in the code that runs in the assembly load context, and then also pending register wait handle instances or timers with callbacks set to methods in the custom assembly load context. One thing that is sometimes it's not obvious what is exactly pointing to that stuff. For example, you can register app domain process exit event handler and point it to something in your in the unloadable context, and that holds it alive forever because it's a static variable somewhere outside of the context that points to that. So you need to have a way to debug that, and that's what the next slide talks about. So as I said, you can get into situations when you think you have everything right and you don't know what is holding the assembly load context alive, but the unload still fails. The best weapon to help to debug it is WinDBG on Windows or LLDB on Unix both with the SOS plugin. So first you need to find out what's keeping the loader allocator managed loader allocator class instance alive that belongs to the assembler context. So use the dump heap SOS command with the dash type loader allocator, which dumps all the instances of loader allocator on the heap. And then you, for the one that you are interested in, you run the gc root -all command with the address of the loader allocator, and it will show you basically the reference chain going from some local or pinned handle or whatever, a register, the logo still, that holds it alive, and then you have to look back and figure out where it came from. It can, as I said, it can be something that the JIT has created, so you might think, what can I do about it? Well, the thing is that the ideal way is to encapsulate everything that you do around the unloadability inside of a function that's marked as non-inlineable, and then return just a weak handle for the assembler context after you are done. And then outside of that, when you call that, and then do the GC loop, and then you can be sure that there are no references, because there cannot be anything on the stack anymore. There cannot be any hidden reference to the loader allocator that would hold it. You can only have the problems that I mentioned that you need to fix somehow and figure out where it and fix it. So as I said, the event handlers, threads running, and stuff like that. And also as you need to view this if this doesn't. If the GC root doesn't show anything, then you probably have threads running inside of that method. So you can view the stack traces of all the threads and see if some of the code is running in the assembler context. That's basically the end of my presentation. Here are some useful links. There is a document on how to debug unloadability. There is the first one is how to use it and debug the unloadability. Then the second one is a sample that basically creates plugins, load them into unloadable context, unload them, and check that they were unloaded. And the third one is documentation, the design documentation. That's the most technical stuff that I've written before finishing the implementation. And actually, I forgotten to mention that when we started to develop this thing, it started in the community. It was not started by the Microsoft people. It was this guy. I don't remember all the guys, but most of the final changes were made by Alexander Mutel, who basically made it so that it almost worked for 90% of the cases. And so I picked up after that and basically finished all the stuff, tested all the cases, find the remaining places where we were leaking memory, not freeing it properly, and stuff like that. And that's it. So thank you.